हरि करना।
Now it's time to take up some examples. So example will begin with rolling a die. So determine which events are mutually exclusive and which are not. That's the first question. When a single die is rolled. So first one, getting an odd number and getting an even number. That's what the question. I think you can easily answer this. Just answer. I'll give you some time. Just answer this question in our comment section. So getting an odd number, obviously. So the possibilities are, this is a compound event and I have designated with a yellow color. So getting an odd number, so obviously from our sample space we can have 1 or 3 or 5. Okay, and on other side getting an even number. This event is again compound event, which is denoted with blue color, dark blue color, and getting an even number is 2, 4 or 6. Okay, so now, so they are obviously mutually exclusive, because if you see this as your sample space, in this sample space you have simple events. We call them as a simple events. Simple events 1, 2, 3, 4, 5, 6. Now these 6 simple events have been made into 2 compound events. One is event A, which is yellow, event B, which is dark blue. Okay, and there is no intersection at all. You see that there is not even a single common event in between. There is not even a single common event. You can see that. I think it's clearly visible. Okay, there is no intersection and not even a single common simple event in between them. So this is obviously mutually exclusive, or you can say them as these two events are disjoint events. Next, question number 2, getting a 3 and getting an odd number. These are two events again. Getting a 3, that's just a simple event, and getting an odd number, this is a compound event with 1, 3 or 5. Obviously you can easily answer this. It's not mutually exclusive, because if you take the event A, which is 3, and event B, which consists of 1, 3, 5, and they have a common simple event which is a 3, so their intersection is 3. When you have a common intersection, so you cannot say this as a mutually exclusive. That's the reason it's not mutually exclusive. I think you can draw the Venn diagram to visualize this also. Then the third question, getting an odd number and getting a number which is less than 4. Obviously this is also, you can tell it. So getting an odd number, this is a compound event which consists of simple events as 1, 3 or 5, and getting an odd number which is less than 4 means obviously you will have this is also a compound event which consists of a simple events 1, 2 or 3. Then obviously what are the common simple events in this? 1 and 3. So the intersection of event A and event B is 1 and 2, 1 comma 2. These are the common events. Obviously if you have an intersection which is not null, it's disjoint. It's not mutually exclusive. That's it. It's not mutually exclusive. Next, so getting a number greater than 4 and getting a number less than 4. So these are the two events. The first event, getting a number greater than 4. Obviously greater than 4 you will have 5 or 6 simple events. Less than 4, 1, 2, 3. So you do not have even a single simple event which is common in both the compound events. So hence the intersection is 0. The intersection is a disjoint null set. So this is mutually exclusive. They're completely mutually exclusive.